Inductive reasoning. This is your first term. It's reasoning based on patterns you see. And I will explain that in class, but please make sure you have this written. Inductive reasoning, reasoning based on patterns you see. Conjecture. A conclusion you reach using the inductive reasoning. Conjecture. A conclusion you reach using inductive reasoning. This is an educated guess. Counterexample. Now you have encountered this one when we were doing the activity where you had to come up with your own definitions and they gave you counterexamples. Those were non-examples. It's an example that shows the conjecture, your educated guess, is incorrect. Describe how you're going to sketch the fourth figure in the pattern, then sketch the fourth figure. You don't have to write this down in your notes, but I do want you to try it. Think about what you think the fourth figure would have to look like. If you need to, pause this slide. Well, hopefully you're noticing that all we keep doing is adding 2 more every time. The first one is half, right? Then we have 4 parts. Then we have 6 parts. So how many parts do you think we're going to have? We're going to have 8 parts. And of course, it's always shading to the left. Now, also what you have to do is you have to describe the pattern. That is, what's happening between each number. Between -7 to -21. Between -21 to -63, and so forth. What's happening? And then I want you to write the next 3 patterns. So if you need to stop this PowerPoint and take a moment to do this, please do so. Okay, so every single time it was times 3. So now all you have to do is take -189 times 3, its answer times 3, and its answer times 3, and there's your answer. Now this goes back to the original example. What will be the fifth figure? We had 4, we had 2, we had 4, we had 6, we had 8. What's going to be the next one? That's right, 10. Okay, now again, describe the pattern. What's happening between 5.01, 5.03, 5.05, and 5.07? And then write the next 3 numbers. That's right. You added 0.02 every single time, and that's how you got your next 3 numbers. Now, what you can also do is you can make and test a conjecture about different things. So on this one, we're going to make a conjecture about the sign of the product of any 3 negative numbers. Product, remember, means multiply. So I want to make a conjecture about if I have 3 negative numbers and I multiply them together, what am I going to end up with? And then you're going to test it by taking 3 negative numbers to see if it comes up with the answer you thought. So my conjecture is the product of 3 negative integers is still going to be a negative integer. Then I test it. -2 times -5 times -4. It still comes out to be a negative answer. Now we're going to move into conditional statements. This is a lot of writing in this section, and there is a lot of note-taking in this section because there's a lot of terms. So please remember to pause when you have to write down the definitions. Your first statement that you need to write down is known as a conditional statement. It is in the format of if-then. If today is Tuesday, then tomorrow is Wednesday. Your hypothesis, also a term, is what follows from the if. It does not include if, it follows from the if. Today is Tuesday. That's my hypothesis. It's the given in your statement. It cannot change. Conclusion. This follows the then. Tomorrow is Wednesday. This is the one that you would have to prove. We would have to try to prove that tomorrow follows from Tuesday, being if today is Tuesday, then tomorrow is Wednesday. So now what we're going to do is we're going to write equivalent conditional statements in if-then form to both of these. I'm going to do these with you, and then you're going to do some on your own. So just follow along with me, and then the next ones when you have to do by yourself, I want you to write those down. So for this first one, all birds have feathers. Well, now what you can do to put it in an if-then form is you can give the birds their proper name. Like I know birds are animals, so I'm going to probably use the word animals rather than say it, because I don't want to use it to describe a bird. I also have to add in some words. However, I cannot change my meaning. So what you first want to do is identify your hypothesis and your conclusion always before you try to write a statement. So my hypothesis, what I'm talking about, is birds. I'm talking about birds. My conclusion, that I know birds have feathers. So my conclusion is that they have feathers. So now when I write this in an if-then form, notice I'm first going to identify the hypothesis and the conclusion. Now in my PowerPoint, my hypothesis is in red, my conclusion's in blue. So for all birds have feathers, I'm going to write if an animal is a bird, because now I'm talking about giving it a name, then it has feathers. Bird has not changed. It's still my hypothesis. It's still what I'm talking about. I'm not going to put all if all animals is a bird, because not all animals are birds. So that would change the meaning. So therefore I just stated about a bird. If an animal is a bird, then it has feathers. The next one, two angles are supplementary if they are a linear pair. I already have an if there. So since I already have an if there, that means that's my hypothesis. So my hypothesis is linear pair. But I don't want to say if they are a linear pair, because they, what are we talking about? They. You don't ever start your sentence with a pronoun. So instead, what are we talking about? We're talking about two angles. So I'm going to put the two angles with my linear pair because my hypothesis is linear pair. My conclusion is supplementary, not two angles. My conclusion is that they end up being supplementary. So I'm going to rewrite this with the if at the beginning. So if two angles are a linear pair, then they are supplementary. So now it's your turn. Again, you're going to have to pause the PowerPoint because I'm going to want you to write these and actually try them yourself. So please pause. Hopefully you wrote something like, if the measure of an angle is 90 degrees, then it is a right angle. You didn't have to have exact like that, but 90 degrees needed to stay in the hypothesis and right angles needed to stay in the conclusion. You could not mix them around because the hypothesis was 90-degree angles. The conclusion was they were right angles. So just to clarify, if the measure of an angle, that's just to give it some clarification of what we're talking about. We're talking about actual degrees. The second one, the 2x plus 7 equals 1 because x equals negative 3, the because is your conditional. Because x equals negative 3, then it follows after that. So you should have wrote, if x equals negative 3, then 2x plus 7 equals 1. Here's two more I want you to practice. So again, please pause this PowerPoint because I'm going to give the answers, but I want you to do these in your notes. I want you to try them. The when, again, is just like the because. When n equals 9, then n squared equals 81. So the conditional statement is if n equals 9, then n squared equals 81. If tourists are at the Alamo, then they are in Texas. Tourists being in Alamo is the hypothesis. Being in Texas is the conclusion. Here's some other conditional statements you need to write down. So again, if I go too quickly for you to copy, you do need to pause the video and you need to sit there and copy these down. These are notes I want you to take. The first one is converse. It's still conditional statements. This is where you exchange the hypothesis and the conclusion. So remember our original conditional, if today is Tuesday, then tomorrow is Wednesday. This would be, if tomorrow is Wednesday, then today is Tuesday. Not all of these have to be true. They can be false. Inverse. Going back to our original, if today is Tuesday, then tomorrow is Wednesday. This is where you negate both the hypothesis and the conclusion. So if today is not Tuesday, then tomorrow is not Wednesday. If you already have nots in the statement, of course you would remove them just like a double negative. Contrapositive. This is where you do both of them. If tomorrow is not Wednesday, then today is not Tuesday. You exchange your hypothesis and your conclusion, and you negate them. Now, we're going to talk about equivalent statements to deal with our converse, inverse, and our contrapositive. The conditional statement and the contrapositive, those two are equivalent statements. Basically, that means that if the conditional, if then, the original, is true, then automatically the contrapositive has to be true. Same thing with the converse and the inverse. If the converse is true, then automatically the inverse has to be true. And same thing, of course, with the false. Please write this down. Okay, so now we're going to do some examples. Now I'm going to do this one with you, so you do not have to write this down, just follow along. But if any time you need to pause because I'm going too fast, please do so. So we're going to write the if-then form, that's your original conditional, the converse, the inverse, and the contrapositive. Then we're going to decide whether or not they're true or false. So remember your equivalent statement. So our conditional statement that we're going to be writing is guitar players are musicians. So remember our hypothesis is guitar players. Our conclusion is musicians. So if you are a guitar player, then you are a musician. And of course that's true, because if you're playing a guitar, then you are a musician. The converse. The converse, remember, is where we went back to the original conditional and now we're flipping it. So the musician now becomes our hypothesis and the guitar player becomes our conclusion. So if you are a musician, then you are a guitar player. Well, that's false. Because just because you're a musician doesn't mean you're going to play guitar. I play the piano and I still consider myself a musician. The inverse. The inverse, remember, is where you go back to the original again and you put nots in. So if you are not a guitar player, then you are not a musician. Well, I don't even have to think about this one because since the converse was false, I automatically know the inverse is false. And last, the contrapositive. This is where you do both. So again, I flip it and I put nots in. So if you're not a musician, then you are not a guitar player. Now remember, my conditional was true. So therefore, again, I don't have to think about it. My contrapositive has to be true. All right, so now comes your turn. I want you to write this one down. Now it's already got the conditional for you, so all you have to do is determine whether or not it's true or false. Then write your converse, determine if it's true or false. Your inverse, determine if it's true or false. And your contrapositive, and determine whether or not it's true or false. So again, please pause this so you can write each statement and tell whether or not they're true or false. So here's your answers. The converse, if a dog is large, then it is a Great Dane. We did the flipping. Large now went with the hypothesis. Great Dane went with the conclusion. Now we still left dog there because we were not wanting to say if it is large. What are you talking about it? What's large? What are you talking about? Dogs, balloons, trees, what? And of course it's false because we have lots of different large dogs. The inverse, if a dog is not a Great Dane, then it is not large. I do not even have to think about whether it's true or false because my converse was false. Contrapositive, if a dog is not large, then it is not a Great Dane. That's where I flipped it and negated it. I did the converse and the inverse. And this, of course, is true. And my original was true. I didn't state it, but it is. Because if a dog is a Great Dane, it's large. Man, those things are big, huge. Okay, here's another one for you. Now, I'm going to give you some information on some of this terminology in case you forgot it when you've had it prior. Polygon is a figure that has 3 or more sides. Equilateral means all sides are equal. Regular, when a polygon is regular, means all sides and all angles are equal. So again, you're going to write the converse, the inverse, the contrapositive, and again tell whether or not they're true or false. Notice the conditional is already given to you. So again, please stop the PowerPoint because I do want you to put these in your notes and take a few minutes to try them. Converse, it's where you flip it. Again, we're talking about polygons. If a polygon is regular, then it is equilateral. That's true. If all the sides are congruent and all the angles are congruent, well, then automatically the sides are congruent. So it's true. Inverse. If a polygon is not equilateral, then it's not regular. Remember, I had to negate both the hypothesis and the conclusion of the original statement. And no brainer on that. If the converse is true, automatically the inverse is true. Contrapositive is where I do the converse and the inverse. If a polygon is not regular, then it is not equilateral. Well, that's false. If you go back to your original statement, it's stating that if all sides are equal, then automatically all sides and angles are equal. Well, that's false. I could have a rhombus. A rhombus has all sides equal and not all angles are equal. Here's a definition that you need to write down. Please write down this definition. Now, we did talk about it before, but we have not really worked with it. If two lines intersect to form four right angles, then those two lines are perpendicular. Now, I will have a picture along with this in the next slide. So if you want a picture, you can draw it with it. You can use the example. But please write this down. Perpendicular lines. If two lines intersect to form four right angles, then the two lines are perpendicular. This symbol we use in our statement, just like we use the congruent symbol. We use this in a statement to stand for perpendicular. And upside down T. All right, so here you are. So there's the picture if you want to draw a picture that shows perpendicular lines. Notice it only shows one right angle, but we have learned from supplementary and linear pairs that the other angles will automatically be 90 because they form lines, so therefore it's 180. They form straight angles. So on this, we're going to decide whether each statement about the diagram is true and explain our answer using the definition. So this is our statement. AC, line AC, is perpendicular to line BD. Well, my goodness, I do see a 90-degree angle. I know then that they are perpendicular, so therefore it is true. Here's the next one. Angle AEB and angle CEB are a linear pair. Well, I know that is true because remember the non-common sides of adjacent angles that are opposite rays form a linear pair. So because ray EA and ray EC are opposite rays, we know those two angles form a linear pair. That was on your test, wasn't it? Chapter 1. This is a definition you need to write down as well. I told you this is a lot of writing in this chapter and a lot of terminology. So please write down biconditional. A biconditional statement is a single true statement that combines both a true conditional and a true converse. So if you have a conditional statement that's true and you have a converse statement that's true, then we know that we can combine them. Back to our original statement, if today is Tuesday, then tomorrow is Wednesday, that's true. The converse, if tomorrow is Wednesday, then today is Tuesday, that's true. So if I combine that, I can combine those two to create a biconditional statement. Now this is how you create a biconditional statement. Oh, by the way, yes, all good definitions are written as biconditional or can be written as biconditional. So here we're going to write the definition of perpendicular lines as a biconditional. Remember your definition? We're going to write it as a biconditional. I'm going to do this with you, but I would still like you to write this down. It's very important. So our definition is if two lines intersect to form a right angle, then they are perpendicular. I left out the four right angles, but it's automatically they'll create four right angles. Your converse, if two lines are perpendicular, then they intersect to form a right angle. Your biconditional, now look what happens. We remove the if at the beginning. We still leave the two lines are perpendicular, but now we slip in if and only if. That right there, the if and only if between the hypothesis and the conclusion tells me it's a biconditional statement. So if and only if they intersect to form a right angle. Now you could have went with the original definition. You could have wrote two lines intersect to form a right angle if and only if they are perpendicular. Because they're both true, so it makes no difference which way we write it. But again, you get rid of the if, you get rid of the then, and in between the hypothesis and the conclusion, you write if and only if. If you needed to pause this to copy this down, please do so. But we're now going to move on to a next one that I want you to try on your own. So there you go. I want you to rewrite the definition of a right angle as a biconditional. Now, hopefully you know the definition of a right angle. It doesn't have to be exact, but if you need to, look in your textbook and look up the definition of a right angle in the glossary section. Take a few moments, pause the video, write it down. Okay, hopefully you wrote down, an angle is a right angle if and only if the measure of the angle is 90 degrees. You could have also wrote, an angle that has a measure of 90 degrees, I'm sorry, I said that wrong. An angle measure that is 90 degrees if and only, that doesn't make sense. Here we go. An angle is 90 degrees if and only if it is a right angle. There we go. That would be writing it backwards. All right, now rewrite the statement as an equivalent biconditional for this next one. Again, stop the slide if you need to and write this down. Okay, so they gave us a conditional. If Mary is in theater class, she will be in the fall play. The converse, if Mary is in the fall play, she must be taking theater class. So again, you can start with either one. This answer started with the original. Mary is in the theater class if and only if she will be in the fall play. We could have said, Mary will be in the fall play if and only if she is taking theater class. Okay, now these ones, I want you to determine whether they're just good definitions. So what we're going to do is you're going to put it in an if and only if, you're going to put it in a conditional statement as well as a converse statement. And if they're both true, then you know it is a good definition. So I'll do number 3 with you. Please write it down, though, so that way you have it in your notes. Take a few moments. Stop the PowerPoint. Okay, if two angles are supplementary, then the sum of their measure is 180 degrees. That's the original statement. Is that true? Yes, right? We learned that. Well, now what if I switch it, doing the converse? If two angle measures sum equals 180, then those two angles are supplementary. Is that true? Yes. Right? Because even linear pair is supplementary. Okay, this one. Write this one down. Stop the slide, because I want you to try this one on your own now. This one's not, because hopefully you saw when you do, if an angle is obtuse, then its measure is greater than that of an acute angle. That's true. But now let's do it backwards. If an angle's measure is greater than that of an acute angle, then it's obtuse. Now, why do you think that's false? What else could it have been? It could have been a straight angle, right? A straight angle is not obtuse. A straight angle equals 180 degrees. An obtuse angle is greater than 90, but less than 180. So when we say that its measure is greater than that of acute angle, then it's obtuse? No. It could also have been a right angle because a right angle is larger than acute angle. So therefore the converse was not making it a good definition.